back to the series circuit where we only had one path for current to flow. Again, in a parallel circuit, we now have multiple paths for current to flow. So which way does the current go? Which resistor does it go through? Well, there's an old saying that says current takes the path of least resistance. And that saying actually is not true. What's going to happen is the current's going to take any path that's available. And how do we know how much current is going to flow through each one of these resistors in each branch? That's easy. As the electrons come along here, coming out of the negative part of the supply, they're going to flow into each branch based on Ohm's law. So the resistance in that branch and the voltage that's across that leg of the circuit is going to determine how much current flows through. So current will flow through like so. Electrons will exit the negative side of the supply, and some of them will go this way to R3. And how many? We look at Ohm's law, and that will determine how much current is flowing based on the resistance. Some of the electrons will carry on, go through R4 like so. And some will go into R5. All those electrons will come back home. R4 electrons, the R5s come this way, and the R3s join in, heading back to the positive side, and together the red, blue, and black will combine so that the total current IT will flow back to the supply like so. That's essentially how it works. Skipping a lot of steps here, we're also going to get to the mathematical analysis of that. So we'll calculate the currents, we'll know how much current flows as opposed to just one single path for current to flow and one IT. We're going to have multiple paths, multiple currents. They're going to add up to IT like so, and we'll get to that just We're going to make this a little simpler. We're only going to use two. We're going to have an R1, R2. We're going to say R1 is 3K ohms, R2 is 6K ohms, and we're going to calculate the currents that flow in each one using Ohm's law now. Current through R1 is going to be the voltage divided by the resistance. So it's going to be V divided by R1, like so. That's Ohm's law. And in this case, the V is going to be the same for both R1 and R2 because it's a parallel circuit. The same voltage exists across all branches of a parallel circuit. So we put in the numbers, and over here we're going to have, just use this area for working, we're going to have 10 divided by 3K. Okay, and that's going to be 10 over 3 is going to be about 3.3, 3.4, and the 1 over 1K is going to turn it into milli, so this will be about 3.3 milliamps. So again, that's the current IR1. Some room. You use green for R2, so the current is going to be V divided by R2. Again, that's Ohm's law. I is V divided by R. So this will be 10 volts divided by 6K ohms. 10 over 6 is about 1.7. and because it's K, it's 1,000 on the bottom, it's going to make it 1/1000th. So that would be 1.7 milliamps, like so. Okay? So IR2, 1.7 milliamps. So the green and red currents are going to come together and merge and create the blue IT, and that will be the combination of both. Both currents have to add up. They both branch off as they leave the power supply. They come back together and add up again. So 1.7 plus 3.3 should be about 5 milliamps. So that's how we analyze a parallel circuit, calculate each branch, the current in each branch, and we can get an equivalent resistance this way because we now have V applied and IT of 5 milliamps. So there's an equivalent resistance of R1 and R2 that is not the addition of R1 and R2. This is different because they're in parallel. The resistance isn't going to add up. The extra current is going to give the impression that the resistance is going down and reducing. So when we do that, we have, just go back to black, our equivalent of the parallel circuit is going to be V divided by IT, so that'll be 10 volts divided by 5 milliamps, like so. And that's going to be about 2K ohms. There is a parallel resistance formula, like the series resistance formula, where R equivalent or R total was R1 plus R2. Resistors were in series. Parallel formula for REQ, in fact, I'm going to go ahead and make a little more room. REQ parallel would be the reciprocal of the sum of the reciprocals, which would be 1 over R1 plus 1 over R2, dot, dot, dot. So if you have more resistors, same thing. This is easy to do on a calculator. There's a shortcut that makes the math a little bit easier. If you only have 2 resistors, it's the product over the sum formula, but that only works for 2 resistors in parallel. If you have 3 or more, you have to use the reciprocal of the sum of the reciprocals. So for 2 Rs only, we have the product over the sum, R1 times R2, R1 plus R2. So this is a pretty easy one. When we only have 2 resistors, product we had was 3K ohms, 6K ohms, the bottom, 3K plus 6K. So this is 18K squared on top. On the bottom is 9K. One K cancels out. This becomes 2K ohms, just like we got earlier. Again, that's the product over the sum for 2 resistors only. And let me go ahead and rewrite the case where you have multiple resistors in parallel for any number of resistors. And it works for 2, and it works for 20. And that's the reciprocal of the sum of the reciprocals. 1 over R1 plus 1 over R2 plus 1 over R3, dot, 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 and 1 over all of that.